Okay, so tonight, a couple things are gonna happen. We're gonna be watching some videos. So the first evening we talked, by the way, only one person watched the video that I know of for response from the first class, but it's up there. So check your emails if you wanna watch the first class. Rodney, who's another instructor, said he watched it. He liked it a lot. I'm going to be observed tonight. Our observer is going to come in about 5:30. Periodically, I think it's every 2 years, we have to be observed and critiqued. So tonight's my night. And then let's see. So this last week first week we talked about how we generate electricity. Second week we talked about how it's transmitted, the electrical grid. And tonight we're going to talk about how it gets from the power pole to our house and how it's distributed in our house. And then next week we're going to do hands-on. So you'll be able to put into practice some of the things that we're going to be talking about tonight. In household wiring, we have some different size wires and different color wires. So I have some samples here. The smallest size wire that we are allowed to use in our residential circuits is a number 14. Number 14 wire. The larger the number, the smaller the wire. So when we have things like lamps in our house, we plug them in, they'll have smaller wires. But this is the smallest size wire that we use in the house. So number 14. Oh, let's do this. The maximum breaker size is 15 amp. Color is white. And use is for lighting only. Now, before, you can sit up here too if you want, or just demonstration. So before, like at my house, I have several plugs in my house. My house is built in '87, and I have several plugs in my house that used number 14, 15 amp wire. So sometimes when you, like in my kitchen, if you plug in a coffee maker and then turn on the microwave, it'll pop the circuit breaker. Or like out on my deck, the plug that's on my deck is a 15 amp breaker. I plug in my compressor there, it'll pop the breaker. So they changed the electrical code now so that you can only use this now for lighting. So if you see somebody wiring, when we do our practicing, we're gonna use this for wiring our switches and plugs. But remember that this is only to be used for lighting, yeah.
Number 14. Number 14.
Number 14.
Oh. How long ago was that changed?
It's been a while, and also it used to be that they didn't have a color code for the wire. So now it makes it really easy when the inspector comes, he can take a look, and if he sees a plug with white wire going to it, he'll know that that's not the code. He'll make you rewire it. Back in the 70s and 80s, a lot of the Romex was either black or white. So you might have circuits that were number 12 wire. So don't make the mistake if you're working on an older house and you see a white wire, don't assume that it's a number 14. It could be that it's a number 12. So you have to actually look at it and see. But in new, it's been at least 10 years that it's been like this, at least
That the 14 has to be used for lighting.
just lighting. Okay, so number 12 is a little bigger wire, a little thicker, and you can use this. This is another 12. See, the numbers get smaller, the wire gets bigger. You can have a 20 amp circuit for this. It's yellow. And this is used for most of your plugs. Most of your plugs. So if I have any of the plugs in my house now, they have to be fed with a yellow wire, a number 12. They have to be fed with a number 12, and it has to be on a 20 amp breaker, not bigger. You can use yellow wire for lighting, but most guys don't. Most guys don't. What it does is it allows you to have more lights on that circuit if you use number 12. So you can actually, because of the, remember from last week that volts times amps equal watts. And so I can only, with a 15 amp breaker in 120 volt circuit, none of these are really good. Here we go. 120 times 15, that gives me 1800 watts. And according to the electrical code, they assume that each fixture is up to 150 watts if you have a light bulb. So if I divide, and the other thing about the electrical code is they only allow you to use 80% of that. So this equals 1440 watts times 80%. So if I have 150 watts, I can't do any more. See, 115, so that is 10. I can't do any more than like 10 light outlets for a 15 amp circuit. But if I have a 20 amp circuit with a number 12 wire, I've got 120 times 20 equals 2400 watts times 80%. 0, 0, 32, 16, 19. So that allows me to do like 150 into that. Was that about 12 or so? A few more. I can do a few more lights in that circuit. So you're using the circuit to power certain situations. The same thing with your plugs. They only allow a certain number of plugs on a number 12 wire in a 20 amp circuit. So you have to follow the electrical code. Also, with the electrical code, you have to have a certain number of plugs. So any wall that's 12 feet or more, you have to have 2 plugs, more than 1 plug. Any space that's larger than 2 feet, like say I came into a room and I had a doorway here. And then here is a closet with a couple doors here. And this is over 2 feet. Any space over 2 feet has to have a plug. Any space over 2 feet has to have a plug. Kitchens are a special situation because in a kitchen, you can't have any more than 2 feet of counter space without a plug. And so like if I did this. You can't overload this. You can't overload the circuit, so if I had a kitchen like this with counter space. And here's my kitchen sink. The code says that I have to have a minimum of 2 plug circuits on my counter. So I would have one circuit for plugs over here, and I'd have another circuit for plugs over here. And then I have to have a separate circuit. We'll get into that a little more, but for the garbage disposal, dishwasher, separate circuit for the refrigerator, microwave, onward and upward. If you remodel a kitchen, a lot of times you have to upgrade your electrical service. Because in the older houses, they only had like 8 or 10 circuits in the panel. So if I was looking in my panel and I only saw that I had 10 circuits, new kitchens require usually a minimum of 8 circuits, maybe 10 to 12 circuits in a new kitchen. So if you only have a panel that takes 10 and you're already using 10, maybe 2 of them are for the kitchen right now, you're going to have to upgrade your service to add more circuits for just for the kitchen. So a lot of times when we're doing a kitchen remodel, we also have to do a service upgrade just to get enough circuit in the panel to be able to do the kitchen. Okay, so the next wire that we have is orange. And orange is a number 10. It's usually has 3 wires in it. 30 amp. $240 volt. Orange. And this is usually for electric dryer, hot water heater, sometimes cooktops, sometimes jacuzzis, but something that requires only a 30 amp 240 volt circuit. We can use the orange Romex. Now, from here on, the Romexes are going to be black, usually. It might be a different color, but they're not defined by a color. So then we have a number 8. This is for the maximum breaker is 40 amp. Again, 240. This would be 40 amp, could be a jacuzzi, heat pump, electric stove, air conditioner. Like that. Number 6 is the next one. That's 50 amp. And same thing, depending on the load required by the manufacturer. And then we have a number 4. And then we get down here to a number 2. And number 2 is for 100 amp. Sub panel. Under and sub panel. Usually. Kind of like that. Any questions? Would you do me a favor? And look on here and see if you can see the size of that wire. I think it's a 2-aught.
No, 604 and around 50 pounds. I think it.
Number 4 could be used, this is like a 70 amp. And it could be used for a sub panel, but the new code requires the minimum size sub panel to be a 100 amp. So it's kind of like you're not really using this much anymore. Yeah. You can use the number 4 sometimes for a 100 amp sub panel, but it would have to be a very short distance, really short distance.
It's a 2-aught.
2-aught, okay. So if I'm doing a sub panel, this is one wire now. This is not Romex. This is, and you can see when the wires get bigger, they start using what they call stranded wire. So the stranded wire has several little wires that make up the bigger wire. About the biggest size solid wire you will see is a number 4. And number 4 we use for grounding your electrical panel. I'm going to talk about grounding a little bit later. But so number 4 is required to be a solid wire. For most wires that are above a number 10, they use stranded wire for those wires, for the individual wires inside the Romex. So this is a solid wire. This would be like if I was feeding the main panel and I had a wire coming from the power pole to my house and then coming in. And if you take a look over here, you'll see that there's wires coming in. What you would typically see on the top of your house, this is called the weatherhead. And the wire that I'm pulling up, these wires here, would be 3 individual wires like this. So one of the wires would have white tape on it so that we know that that's neutral. So if you see inside these guys, they call this this is 3 wire here, 3-wire Romex. It has actually 4 wires in it. But they call it 3-wire Romex because they don't count the ground. So typically in 3-wire Romex, which we normally use either for, we used to be able to use this for having 2 circuits. You would use a common neutral for the 2 circuits. So I'd have a black wire going to one circuit. I'd have a red wire going to another circuit. And then for the electricity coming back, I would use what's called a common neutral. Doesn't work anymore. Now we're required to use these new circuit breakers called arc fault circuit breakers, and it will pop the breaker because it senses that there's a short because electricity is coming from 2 different sides. So now if I'm running 2 separate circuits, I have to have 2 Romexes that have just a black, a white, and a ground. Okay, so you can't, unless I'm running a 240-volt circuit where I have 3 wires like this. This would typically be how you'd run a 240-volt circuit. So like if I open this up. This is 240 volt number 10s. You see that it has the 3 wires, and the red wire would be for one leg 120, the black wire would be for another leg of 120, and the white wire is your neutral. So the electricity returns back on the neutral, and then we have a ground in case there's a short. There's a ground in case there's a short, so. For 220 volt, for most wirings. The most, I say, the black wire or the colored wire will be your hot, where the electricity is coming in. The white wire is going to be your neutral, where it's returning back. And either the green wire or the bare wire will be your ground. So if you see a green wire or a bare wire like this, you know that's a ground. Now, if I'm running my wires as individual wires through a conduit, and you can see on the panel over here that we have different kinds of conduit. Let me do this. We have weatherproof conduit, we have flex conduit here that's metal. It's usually either steel or aluminum. This is weather tight again. This is for outdoor applications. And then they have some plastic conduit here. But so in these situations, you're not allowed to run Romex by code through a conduit. So you have to run individual wires. So in that case, I would have a green wire for my ground. And so don't see any green wire. Oh, here's one. Here's a green wire in my box. So the ground, you can always tell that the ground is either going to be a green wire or a bare wire. Any questions about it? Yeah.
Why can't you run Romex through conduit? What's the problem?
Heat.
Oh,
Heat.
thank you.
Anytime you have electrical circuit, there's heat that's generated, so you might have a meltdown because the heat's going to be allowed to build up inside there. You might have a meltdown of the individual wires and then you get short. Okay. Who came in? What's your name?
Presencio.
I did up there. Hold on one second. Over here, I don't know. There you go.
Jalen.
Jalen, yeah. Stronger, I got it. All right. Could you turn one of the light switches down, please?
Machines that transfer cars to movies. These the top of utility.
Just one.
On the ground in your neighborhood. The transformers are used to step electric voltage up or down before it makes its way to its final destination. Why does this need to happen? Original power distribution voltage can range from 70 to 100.
Can you do closed captions?
Do what?
Closed captions?
Like so.
Oh, yeah.
I'm not sure how much this is picking up the audio, but I just.
Let's talk about transformers. The machines that transform cars to combat robots you see in the movies, the kind you see at the top of utility poles or on the ground in your neighborhood. Transformers are used to step electric voltage up or down before it makes its way to its final destination. Why does this need to happen? Original power distribution voltage can range from 7,200 to 24,900 volts, depending on your electric utility provider's practice, the distance to the furthest member, and the amount of load served. That's much too high a voltage for safe home or business use. Transmission lines connect the power to substations brimming with transformers and control equipment. This is the first place where a transformer is safer or manageable for the distribution system. The voltage then travels through distribution lines, takes one or two more steps down, and arrives at your home. Power feeds into your home's electrical outlets and lights at 120 volts. Water heaters, ranges, and HVAC systems receive 240 volts, both considerably lower than the original voltage. Here's a quick look at how transformers actually work for a typical American home. Transformers start with an iron core. On two sides of this iron core, wire is coiled. On the high voltage, the coil is wrapped around the core. Many times, this side receives or produces high voltage. On the other side, the coil is wrapped around fewer times, receiving or producing lower voltage. As the electricity flows through the high voltage coil, it creates a magnetic field that induces a lower voltage in the other coil. That's how the magic of transformation takes place. Transformers are everywhere in our daily lives, not just in your utility providers' lives. Take your cell phone charger, for example. Many of these small cousins of utility transformers perform a similar function. Charging your cell phone with 120 volts will riot instantly. The charger converts the voltage to a more powerful 5 volts or so. The use of electricity touches nearly every aspect of our modern lives, and we have transformers to thank for bringing it safely into our homes.
So we kind of covered that last week, and so we have a transformer outside. Usually transformers will serve anywhere from like 2 to 6 homes. And you'll see the wires that come after the transformers will have wires feeding the individual houses. So I might have a power pole here with a transformer on it. And then from the transformer, there might be some lines that are going along like this. And you'll see that instead of your house being connected directly to the transformer, your house wiring is connected to this wire somewhere along the line. Well, what that means is this is already reduced past the transformer. It's already down to 240 volt, and they're going to tie into that line. So you can only do a couple of houses with that because you start getting a bigger drop than if the houses were connected directly to the transformer, which is more common. Like in residential neighborhoods, like if I had a neighborhood and there's a house here in a backyard, and then we had another house here, usually you'll see those power lines going through the neighborhood, and you'll have a power pole here with a transformer, and it will connect all these houses like that, something like that.
Morning, Sparky here. How are you guys doing today? Got myself a new headset. I wanted to try them out this morning. Just a quick little video here. What we have is a 200 amp overhead mass feed. Is coming off the utility pole. And these 3 wires here is single phase residential home. And these 2 wires here are aluminum. And the cable on the center there is your neutral. It's also
Yeah, the 2 white wires, which would typically be black, are aluminum feeds. Edison usually uses aluminum wires for their feed lines. And you'll notice that they're smaller than the wires that we have coming up to this is called the masthead. And this is called this is the mast, and this is the weatherhead. So my wires coming out of the panel, coming out of the top of the panel, they'll be coming out of the top here, and they go up to the roof. And then there's a weatherhead like that where the wires from my panel will stick out. And then Edison connects their wires here to the wires that I have coming out of the weatherhead. And that's how they connect up. And they have special connectors that do that. So you have your 2 120 lines, and then he's going to explain what the neutral wire is here. It serves 2 purposes.
aluminum, but it has a steel cable inside of that called the carrier cable. And
Yeah, so the carrier cable inside the neutral also is used to support the wires so that they don't fall down. So you have a steel cable in the center of that that's attached to the your pole here, and it will support the other 2 wires. Hi. This is Norma. This is my class. Say hi to Norma.
And are
that's what is tied around the master for support from here to the pole. It's about, I don't know, 40, 50 feet out to the pole. It's not very far. One of the things that I wanted to point out was that the insulators out here in our Arizona sun, they've kind of deteriorated and fell off. They actually found them in their yard. And these are actually just a couple inches away from that the neutral there. So when the wind gets to blowing, it gets pretty close to shorting out. This is copper coming in through here. It's pretty stiff, so it's, you know, it's not.
Here they use special insulated connectors for making these connections, so you wouldn't have that problem of it shorting out. When they connect my wire to the pole's wire, there's a special connector that's insulated, and they crimp those together so that it's holding it.
Likely, unless we get really, really high winds, that these 2 things are going to short out. But nonetheless, I've told the owners that they need to get a hold of the utility company and get them out here and get these covered up. You know, it's a safety thing. I'd hate for those to happen, you know, in the middle of the night. But anyway, just wanted to show you that real quick. Not a big deal. Hope you guys have a great day, and I'll talk at you later.
So you see what the weatherhead and the connection looks like there.
Don't take shortcuts when it comes to permanent outdoor lighting.
Anything I need to do, Norma? Just hang out?
Yes.
Okay.
keep going.
Okay. All right. I didn't down.
Hello, my name is George Crump. I'm the electrical technology instructor here at Kansas City, Kansas Community College and the Technical Education Center. Today, I'm going to talk to you about service entrance as it relates to all the customers in the Wyandotte County area being supplied power by the Board of Public Utilities. What I have beside me here is an example of all the code requirements that the Board of Public Utility requires when you are installing electric service to a home. And we will start at the very top, and I'll go through the various components in terms of the parts, starting with the weatherhead, which is located up here at the very top. And then from the weatherhead down, the 2-inch conduit that you see right here is called the mast. Anytime the
So here in Santa Barbara, on some of the older homes, you might see a 1-inch mast, you might see 1.25 inch mast. The new code for your mast is 2-inch. So you have to have at least a 2-inch mast coming out through your roof to go out. If you're doing underground cable, you have to have a minimum 3-inch, this is 3-inch PVC conduit to run your wires underground from the power pole to your panel. So Edison requires that you have a minimum of 3-inch, sometimes depending on the size of the service, they might, or the distance, they might require you to do this in 4-inch, which is really huge for when you only have 3 wires coming in. Now, Edison supplies the 3 wires. The 3 wires that we were talking about in the last video, but all panels have to be grounded. So the electrician has to supply the grounding to the panel. Edison doesn't do the grounding. We have to do that. Stephanie.
2-inch conduit comes from the roof line up, is considered to be the mast, M-A-S-T. Then you gotta support that 2-inch conduit by way of this guy wire, GUI wire, that's 3/8 of an inch in diameter, and supported with a roof high bolt here on.
So it's a little different here than in this video. It used to be that we could do it this way. But because of the earthquake codes, now when we put our mast in, it has to be inside the wall. So that when it comes through the roof, I have inside my framing with a double top plate, and then my panel is going to be usually sitting in the wall here, and my mast is going to come up through that top plate and through the roof. So now the top plate, double top plate, and my roof is supporting the mast from falling over in case of an earthquake. You have extra support, and so we have to, if we're retrofitting or putting in a service upgrade, even if the old panel was here with a mast on the outside, we have to open up the wall and put the mast on inside the wall through the double plate and through the roof. So it gets that double surface so that it doesn't fall over in case of an earthquake. Or high winds. High winds do the same thing. High winds can blow your wires back and forth, so that might pull your mast over also. So this acts for both earthquakes and high winds to really support that mast so that it doesn't fall over.
The top of the roof. Then, in addition to that, you will have flashing. This area right here around the roof where the 2-inch conduit goes through the roof must have flashing there in order to prevent water from transferring down into the electrical system. Down below here, you have another continuation of that 2-inch conduit at this point, and you must have a clamp that clamps and secures the conduit within 6 inches of the box. That is a code.
We still have to have a clamp. What we do is we put a block in the wall and we clamp that mast to the block that we put between the studs in the wall. So if I had a stud here, and then my panel sits in the wall like this, and my mast comes up, I would put a block in behind it, and then I put a clamp on it here to strap the mast to, so you're getting support from both studs in the wall, and where it goes through the double top plate, you're getting support here where it goes through there, and then through the roof. You're getting support again there. So we have to do this also, even though it's in the wall.
requirement. And then from that point downward, you'll have a hub, and that hub is a connection at the top of the meter can to screw in the rigid metal conduit that carries the conductors from the meter back up to the weatherhead. Below that, that hub that's here over top of the meter can that's secured to the meter can, you have the meter can. This is the meter can located right here. And then this meter can is supplied to you once you get the proper approvals from the Board of Public Utilities to install the service for the home. You have to have that approval before any work will begin. Then below that, you have this meter can in which this is an older style of meter, which has the dials on it. Most of your homes today that have new service has the digital meters that replace this old style of meter. And to the side here, I have several displays that I want to briefly talk about. For example, over here is a picture showing all of the code requirements by the National Electric Code that provides you with the distances that different things have to be located when it comes to installing service interests for the home.
So the way he's showing it would be the way this is right here. You have a meter main, so the electrical comes into the box, a separate box where the meter is located. And then from the meter, it goes through a conduit that Edison controls, and then it comes into your service panel. Most of the time now, what you're seeing is that the electrical panels have what they call a meter main. So both the meter and the circuit breakers are all together in one panel. So the panels are much bigger now. And so you have to create a bigger space in the wall for those. Because now, most of the time with the arc fault circuit breakers, you're going to need a panel that's going to need at least 40 breakers. Used to be that we could divide the breakers into what I call splits, where there's one breaker spot, you could have two separate breakers in that slot. Can't do that anymore. With the arc faults, you need a slot for each breaker. So the panels are much bigger, and you still have your meter built into the panel also most of the time, instead of doing it that way. You just buy one box, one panel, and everything goes in there. Your circuit breakers, your meter, everything is all in one.
And then below it, you have the Board of Public Utilities requirements. The Board of Public Utilities would be considered the authority having jurisdiction because you are putting electrical service into their service territory. Therefore, they have their own specifications and requirements that you must adhere to. And then over on this page of this display, you have two types of displays. The one at the top is showing you the mast going up through the roof. And it's also giving you a clearance from the ground, which is the grade level, up to the drip loop, which is the conductors coming out of the weatherhead. And from the ground to the drip loop, there is a 12-foot clearance that has to be adhered to in order to get the proper approvals for the installation to be done correctly. Below here, you have a different setup where you have a clearance on the meter can up to the weatherhead that's on the side of the home underneath the eaves. When it's underneath the eaves, you still have to have that clearance from the grade level up that the BPU, Board of Public Utilities, requires in order for it to be able to pass inspection, because all this will be inspected by the city inspector. And below that,
So when you install the panel, there's a code of clearance, so you can't have a tree or a bush or something right in front of your electrical panel. You have to be able to service it in case of emergency, and it has to be a certain height off the ground to the center of the panel. Usually we shoot for about 4 feet to the center of the panel, and then part of it might be above that. It depends on the size of the panel though. So there is a code for both of those things.
Beyond that, brother say, you must have the meter can exactly 5 feet, 6 inches to the center of the meter base in order for the Board of Public Utilities to approve your,
So their height is 5'6" to the center of the meter bay. But the panel's below that. And when we do a meter main, we just set the whole thing at about 5 feet. And so that puts the meter up where he's talking about, puts the breakers in another place. So
your work as falling into the category of what they consider to be proper and fitting for the home. That is the primary parts and also the information that I wanted to share with you today in terms of whenever you're gonna do service installation, you must have all of these specifications as it relates to the Board of Public Utility and the National Electric Code. If you run into any problems, I would suggest you call a certified or qualified electrician in order to help you. These are not for everyday homeowners to attempt. You must have an electrical background and you must be familiar with the authority who has jurisdiction as well as the National Electric Code. What you see before you are two distinct drawings which shows the service interest requirements. One is the service interest requirements by the National Electric Code and the service interest requirements for the Board of Public Utilities. And since we're in Wyandotte County, the National Electric Code requirements for service interest will be superseded by the Board of Public Utilities requirement.
right, same here. Let me go back a little bit for this. If we had, this is a 2-story house, but the National Electrical Code says it only has to be at 12 feet to clear objects in the yard. But if we had a 2-story house here, the electrical service has to be above the upper roof, above the 2nd story. So we would have to do the same here as it's shown in here. It can be at the lower level. It has to be up above the roof there.
County, the National Electric Code requirements for service interest will be superseded by the Board of Public Utilities requirement. Over here on the National Electric Code, you have a 12-foot requirement from the ground, which is called the grade, up to the service interest drop, which is the actual conductors coming from the utility, that has to be at that height in order for it to be the proper clearance. The next requirement over here on the National Electric Code, if by chance you have a front porch and you got an overhead line going down to the house that goes over that front porch, from the very base of the front porch, there up to the service drop, there must be a clearance of 10 feet. And then if by chance you have a 2-story home, you must have a 3-foot clearance from the roof line of the 1st story up to the service interest drop. And then if there's a window close by, there has to be at least a 3-foot clearance between the service drop and the window. And then going further back on the home, at the roof, if your service is coming in on the back of the home on the 2nd story, there has to be at least an 18-inch clearance from the bottom of the roof line up to the top of the service interest cable. And if there's a balcony on the back of the home, you have to have a 3-foot clearance from the balcony, and from that 3-foot clearance, you need to go up 10 feet for the service interest that goes over to the home. That clearance must be adhered to as it relates to the National Electric Code. The next portion of this National Electric Code that is showing you is service interest conductors going to the home that goes over a roadway in which you have this access for a tractor trailer. Any type of roadway that the service interest goes over, you must have an 18-foot clearance from the grade, which is called the ground, all the way up to the lowest point on the overhead feeder. And then if you have a service coming into a garage, and the garage has a flat roof on it, there must be at least an 8-foot clearance to the bottom of the service coming into the garage. Now, those are all the basic requirements for overhead conductor clearances as it relates to the home and a garage. There is the BPU requirements. We spoke about the 12-foot.
Also, you can't have a cable, your service drop going over a swimming pool. So in case high winds or something and that cable broke, you're doing the backstroke, you would be very excited when the cable dropped into the pool. So you can't have a cable going on. So there's a lot of different individual codes for when you have service drops. And we're not going to talk about them all. Some areas, they require that your service be underground. So if I'm doing a service in Hope Ranch, I have to do an underground service. But not all areas. Some neighborhoods, like up in Bel Air Knolls off of Las Positas, they're all underground service. So some areas you're required to do underground service, which gets to be more expensive because you have to trench, you have to put in the conduit, you have to put a pull box in for Edison, you have to put a big heavy duty rope in here for them to pull the cables through. So you have to do all those things for when you're setting up for an Edison full as an underground service. Also, you're not allowed to have more than 180 degrees in bends. So they're pulling really big wires. Like if you're putting in a new 200 amp service, your wires are going to be big. I showed you what it is. This is for 100 amp service here. Imagine a wire that's 4 times as big as this and having 3 of them for a 200 amp service. The wires are about $12 a foot. At least, and you got 3 of them. So that's why they require this. It makes it easier for them to pull those big heavy wires through for a 200 amp service. If an electrician was doing it and he was pulling a 200 amp service to the garage or something, he'd probably put in a 2-inch because you can pull a wire through that. But Edison wants great big pipe.
Clearance down to the bottom of the drip loops. That same 12-foot clearance over here on the National Electric Code is also what the Board of Public Utilities require, except it goes from the grade at this point, which is the ground, up to the bottom of the drip loop on the conductors that the utility will hook their lines into to provide service for the home. There's a 5-foot 6-inch clearance from the ground up to the middle of the meter, which is installed by the Board of Public Utilities. Customer, which is your electrician, must also install behind that meter can 3/4 inch plywood on the home to mount the meter can on. So in the event there's rain or whatever that goes down the side of the house, it will not flow into the meter can by putting that 3/4 ply inch on.
In the Midwest, in places where it's cold and like that, a lot of times you will see something set up like this where they have the separate meter on a can, and then the main electrical panel will be inside the house. Because in the middle of winter, you may want to go be chasing out in 2 feet of snow to reset your breaker. So typically, they're going to have the meter can on the outside and you're going to have the panel on the inside. Could be, it has to be accessible, but maybe on a basement wall, maybe upstairs in the bedroom or something where it's accessible. You can't, it used to be we could stick a sub panel in a closet. Can't do that anymore. It has to be accessible. It has to have 5-foot clearance around it so that you can get access in case of emergency. You see people putting pictures over them and all kinds of stuff. That doesn't meet code. It has to be accessible.
A way that keeps the meter base away from the home. The next thing that I'm going to speak on is going to be the 2-inch conduit that you see here on the drawing that's going up. And that 2-inch conduit has to be secured 6 inches before or 6 inches beyond the meter can. and then it travels all the way up to this top portion of the roof line. And right here on this roof line, there is flashing. And that is an aluminum construction that fits around very snugly around the 2-inch conduit to prevent any water from seeping down into the electrical system. And then above it, you have a service loop that is supplied by your journeyman electrician. And this service loop allows the BPU, when they come and hook up the drip loop, which is made like a gooseneck, when they come and hook their service up to that drip loop, they also have that service loop to support the drip loop. And
Yeah, so you have the weatherhead is pointing towards the ground, and then you have a drip loop here. So all this prevents rain from coming inside and going down into your electrical system. So, yeah, around.
Could we put the box in the garage, not off the?
Your main service is going to be on the outside. You're required to have the meter on the outside.
Is that what we couldn't put in the
You can't,
house or in the?
the main meter has to be on the outside.
Thanks.
You know, and I don't understand it because now they're all read by satellite or different ways now. No, but they don't have meter guys that go around and read them anymore. So
Doesn't the main shut off have to be on the outside for the fire? Yeah.
it's gotta be there. It's gotta be on the outside. Exactly.
then in addition to that, if the rise, which is called the mast, this is the portion that comes from the roof line up to the top of the weatherhead. If that mast is above 22 inches, you have to put a 3/8 guy wire rope that is attached to the roof to secure and make sure that that mast has support in the event.
It's not a rope, it's a steel cable, so don't get confused when he says rope. It's not a rope, it's a steel cable.
Of high winds or any type of severe weather that we may have. If you have other questions about the specifications on installing service entrance, by all means, go to the website bpu.com or call your Board of Public Utilities customer service to find out what are the requirements that you need to have if you don't have access to a computer.
Any questions? You guys have some great questions. That was really good. So, like James was saying, here in Santa Barbara, we're in a high fire area. So in case of a fire, you know, they have guys that will go around, they'll shut off the gas meters, they'll shut off your electrical. They have to be able to get to those on the outside of the house. They'll shut your water off because like in the mudslides and stuff, they had a bunch of fires that were started because the gas lines got busted and the gas was free flowing. Well, in a fire, you don't want that gas to be free flowing. It's going to cause explosions and stuff. We're in an earthquake. A lot of times people nowadays install these automatic gas shutoff that in case it jiggles a certain amount, it'll just shut the gas off. We've installed them for clients. I don't have one in my house, but it's not a bad idea to have an automatic shut off in case of earthquake. Any questions? Yeah.
How far should be gas inlet and electric inlet? The distance between them?
Well, you're not supposed to have, like, if you were doing underground service, you're not allowed to have them in the same trench. You have to do separate trenches. I don't know the code for
Distance between-
keeping the distance from gas meter or gas meter to the electric meter. I don't know that. I don't know the answer to that. As far as I know, there's, as long as you have some amount of clearance to gas meters down here, it's not a problem. But I can't tell you the exact code. I don't know.
But they don't shoot close together, yeah?
Well, a lot of times they are close together, but a lot of times when you're trenching, you're gonna try to do your trenches pretty close together. So that,
Other trenches are not together with one trench for the pipe of the gas and one other trench. for-
yeah, but say I'm building a house, which I'm doing right now. And I have. My house is here. And over here. Is. My gas entrance from the street. And then along the sidewalk here is my power plant. Okay. If I'm doing an underground service, I'm gonna do a trench here. To get my electric here. In my gas, I might have my gas meter here or something, so. You're just trying to keep the trenches separate. Right?
Yep.
But. Typically, you're gonna put the electric meter on the side of the house, it's not gonna be in the front, but a lot of times the gas meter will be in the front. It might be on the side too, maybe I run this and I put my gas meter over here sometimes. So it's usually it's convenience, and Edison will tell me. Because it's at a certain height, my gas meter's down here. It just can't be in that 5-foot circle that I have to have around. My meter as far as I know. You can't have anything that gets in the way of this, so
So you have.
you're required to have this. 5-foot circle here. Around the meter.
So maybe you have a restriction for all of the maintenance like water, gas, or
Yeah, water's gonna come in. I can run my gas and my water in the same trench, so you're gonna make it as convenient as possible. Otherwise, you have a lot of extra cost in just trenching and running your pipe in different trenches and things like that. So, people are really, with how expensive things have gotten, they're really price conscious about what individual items cost. Yeah, anything else? No, you don't love me anymore? Okay. So this video here is explaining the panel. Now we got the power coming in, we've got our weatherhead, we've got the electrical wires coming down to the panel. This is going to explain what the panel does. And if anybody needs to take a break, we can take a 10-minute break now if you want to. Nobody? Want some water? We're about halfway through.
Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Connected to the distribution cables will be smaller transformers, usually pole mounted, which reduce the voltage down to a level safe enough for residential use. On the property will be an electricity meter, which will quantify how much electricity has been used, and the electricity company will use this to invoice the property. So if we zoom into the property, we find a main service panel, which is sometimes called a load center or breaker box. If we remove the cover and look inside, we first find the main breaker, which is usually at the top of the panel, but it might be at the bottom. The two hot wires from the electricity meter will connect directly to the lugs on the main breaker. Coming out of the main breaker will be two main bus bars. These are basically exposed metal sheets which carry electricity to the circuit breakers. Notice I've shown the current going backwards and forwards. That's because this is.
So, in this is just like that. Wires come in here, the attachment for the pipe is missing here. You have to buy those separate when you buy your panel. But you can see that there's a screw here for 120 volt lug and another 120 volt lug. And then these go opposite each other. You can actually see, like the way he's describing it, these do exactly the same thing. It's just like that. So, and this is my main breaker. So when I turn it off, it's shutting off the power to both tracks here when I turn it back on. And when you have it, this is a 240 volt breaker, right? Because you got 120, 120, 240 volt. And on all 240 volt breakers, it's a double switch for each leg of the 120, 120. They have to be joined together. It's NEC, National Electrical Code, that you have to have those two attached. Because what would happen if I just shut off one to my electric stove and then I went to work on it? You could get electrocuted because you didn't shut off the electricity to both sides of it. So when you have a 240 volt breaker, they have to be joined together. So you make sure that you've got both sides turned off when you're doing that.
We say to this one 2 pole or 2 single switch.
So you can put singles all in here, each one of these metal
No,
clips.
the briquette, this 2 pole now or not? Because you select one and or 2 switches. The briquette.
This is 2 switches.
I know, the 2 switches, we named him it 2 pole or not?
No, the single
No
pole still.
Single pole, 2 switches.
Yeah.
What meaning the 2 pole? It's different with this briquette?
So that you have single pole or 3 pole, 3 phase. Yeah.
Well, when we have 3 phase, we should.
You have a third feed wire.
And 2
This
pole,
is how electricity is generated at the power plant. It's generated and transmitted in 3 phase.
I worked in home before, in electrical department. Guys.
Oh, I've
comes-
seen you there.
Yeah, gentleman comes and told me.
I don't
that-
recognize you without the orange apron.
Yeah. So they want the 2 pole and sometimes they want 2 single switch like this one. One switch with 2 trigger for 2 of them. So 2 pole means other thing, yeah.
Well, you could say this is 2 pole because you have 120 and 120. But generally we say this is single phase.
Single phase
Yeah.
or 2 switch.
Or 3 phase.
Filter.
Yeah, single phase or 3 phase.
2 pole, what meaning 2 pole?
You have to have 2 120 volt circuits.
Oh, 2 1.
Single pole, double pole, 2 breakers.
I got it.
Yeah.
Thank you.
Did I explain that right?
Yeah,
Okay. You got it?
Yeah.
Yeah.
thanks.
Yeah, so 3 phase is more for industrial. We don't use it usually in residential homes. I have a client of mine. He has a CNC machine, the big heavy duty like metal machining machine, and it's 3 phase machine. So he has an adapter that will change it from single phase to 3 phase. Yeah. But typically, we only use 3 phase in big, heavy industrial areas where like you're using 440, 480 volt or something bigger, yeah.
Thank you.
AC or alternating current. These bus bars, as well as the lugs, are not insulated, they are live or hot. The main breaker can be manually flipped to cut the power to everything downstream of the main breaker. The main breaker will also provide overcurrent protection to the property. It is rated to handle a certain amount of electrical current passing through it, typically between 100 and 200 amps. If this value is exceeded, then it will trip automatically to try and protect the property and its electrical circuits. Inside the panel, we also have a neutral and ground bus bar. This is basically a strip of metal with lots of holes and screws in it. The neutral and ground wires will sit in the holes and the screws will lock them in place. In this example, we have a block on either side of the panel. As this is a main panel, the 2 bus bars can be joined together. So we have a connector bar between them. That way we have a shared neutral ground bus bar. Sub-panels must have their bars separated, but that's a topic for a separate video. From the electricity meter,
I'll just review that really quickly. So in your main panel, this is my ground bus bar on this side, and this is my neutral bus bar on this side. And this is where the white wires go, right? So the neutral bus bar is where my white wires go. The ground bus bar is where my green or my bare wires go. In your main panel, see this little doodad here? This has to be connected to the ground bus bar, to the neutral bus bar, so that the ground bus bar over here and the neutral bus bar over here are connected together. In case there's a short and it hits a neutral wire, we want that neutral wire to be able to get it to the ground bar. So a lot of the old panels didn't have a separate grounding bar. You would see the white wires and the ground wires all on the same bar. It's basically going to the same place. Okay, just returning the electricity.
What about for the sub? Oh, sorry.
Sub panel, they have to be separated. They have to be separated. Because the way it works, it would actually be creating a short. It would actually be creating a short. So you don't want that to happen. More complicated, and we're not gonna talk about that. Yeah, maybe next week. Good question. So, yeah, so if this was my sub panel, I wouldn't connect this. I would just put my cover on here. This would be my sub panel. I'd have on my main panel, I'd have a shut off for this. And then in this panel, I have a shut off for it too. So you have to have separate shut offs at each place for this panel.
We have the neutral wire connected to the lug on the top of the neutral ground bar. Notice the green screw. This is bonding the neutral bar to the metal casing of the service panel. The purpose of the neutral bar is to return the electricity back to the transformer. It does actually get a little bit more advanced than that, but we're going to look at that in a more advanced, complex video. This is just covering the basics. So the two hot wires will provide electricity, and once it is used, it will return to the transformer via the neutral bar. It is still AC alternating current, but to make it easy to visualize, I've only animated the current flowing in one direction, so you can see the path it will take. Now, if we were to take a multimeter and connect one lead to the bus bar and the other lead to the neutral bar, we would get a reading of around 120 volts. If we connect the multimeter leads to...
And Edison is required, Southern California Edison is required to supply us electricity that's within 5% of 120 volts. So if I test, like at one client's house, we tested it, it was 119.5 or something. It was really close to 120 volts. And we had to replace a panel in Hope Ranch and run a whole new underground service and everything. They had the wires coming from one power pole and they had a buried cable. So back in the day, they would allow you to run just a buried cable. It was an insulated cable. It was meant to go in the ground, but not in conduit. And on that one, we were and we got like 79 volts on one leg, and we were getting like 86 volts on the other leg. So something was definitely wrong, right? So we ended up figuring out that they had a short in the neutral. So somewhere along the line, a gopher bit into it, or somebody got into that wire, but they were definitely not getting the voltage that they needed for the house. And when Edison might get the power coming off that pole, it wasn't steady. They weren't getting a steady flow. So they actually made us in Hope Ranch, they're minimum 1 acre parcels, and the house was sitting up here. And the old power pole was here. They made us go to a power pole over here and run it underground all the way to over here. So it was a long run and it was an expensive pole. But now, after we did that, everything is fine. They're getting a steady 120 volts on each leg. The neutrals are in conduit. Everything is good, and you know, it'll be good for a very, very long time because everything is covered and protected. You might ask, what did we do with the barricade we left?
Did Edison at least disconnect it, or it's just?
Well, we'd have to dig it all up and it's at least three. Code is required, when we were putting in, this underground conduit. They required it to be at least 3 foot in the ground to the top of the tube. So we had to dig down like 3.5 feet. And then you have to use yellow sand, to identify the pipe. When you're covering it up, it has to sit in yellow sand and you have to put yellow sand on top. Then you can put native soil in after that.
How deep you gotta go for a sub panel? Like, I mean, 18?
For what?
For a sub panel?
For like phone line?
No, just for like a AD, whatever, like another building?
Oh, well, if I'm running it from the main panel, it has to be 2 feet.
Okay,
Yeah, 2 feet.
not 18?
I do 2 feet. Yeah, I do 2 feet. Safer. For plumbing, we do 18, gas, things like that, but electrical, I do 2 feet. You good? Yeah. Okay.
The other bus bar and the neutral bar, we would again get a reading of around 120 volts. But if we connect the multimeter leads to the 2 bus bars, then we get a reading of double that at around 240 volts. So why is that? What's happening here? So when we look at how the transformer is connected to the main panel, we have the 2 hot bus bars connected to either end of the secondary coil in the transformer. And then we take the neutral bus bar connected to the center of the secondary coil. So basically, when we connect across the bus bar and the neutral bar, we're only using half of the coil. So we are only picking up half the electrical voltage the transformer can provide. So that way we get 120 volts.
I find this really interesting, the way they do this. They're only using half of the windings on the coil for each leg. Maybe it's me, but I think this is really interesting.
When we connect to the 2 bus bars, we're connecting to the full length of the coil. So we're picking up the full voltage which the transformer can provide. Therefore, we get 240 volts. Now coming back to the panel, connected to the bus.
And I just want to go back a little bit. Remember, it's an AC current. So the current is going in both directions. So that's what he's showing back and forth.
Therefore, we get 240
69 per
volts.
second,
Now
65.
coming back to the panel, connected to the bus bar, we'll have our circuit breakers. These will look something like this with this black plastic casing and a toggle switch on top. The circuit breaker controls the flow of electricity into individual circuits in the property. It can be manually tripped to cut the power, but it also has 2 important features. The first feature is overload protection. The circuit breaker is rated to handle a set amount of electrical current. When appliances or lights are connected to the circuit, they will each increase the current in the circuit. If too many things are plugged in and turned on, then eventually the current will be more than the breaker can handle, and the breaker will automatically trip to cut the power off to the circuit and protect the property. The second feature is short circuit protection. When the hot and neutral come into direct contact with each other, the current will dramatically increase almost instantly. When this occurs, it creates a magnetic field which will trip the breaker and cut the power automatically. Let's have a look at how the circuit breaker is connected to the electrical circuit. In this example, we will connect to a simple light fitting, which is controlled by a switch. We take the hot wire from the circuit breaker and run this to the switch. We then run another wire from the switch and over to the light fitting. From the light fitting, we have a neutral wire, which carries the return current back to the neutral bus bar. We take the ground wire.
Pay close attention that in the white wire doesn't connect to the switch at all. The white wire doesn't connect to the switch at all. I'm going to show you this a little bit later with the switch.
Wire from the metal casing of the ceiling box and the switch, and we also join this to the neutral bus bar, as in this case it's shared. The purpose of the hot wire is to carry the electrical current over to the light fitting. The purpose of the neutral wire is to carry the used electrical current back to the main panel and then back to the transformer. The purpose of the ground wire is to provide protection for a fault current. If, for example, the hot wire came loose and touched the metal casing of the light fitting, the ground wire provides a low resistance path back to the panel. Without this path, electricity could flow through you if you touch the metal box. As the current flows through the ground wire, it will increase the current and that will trip the breaker automatically. So the electricity flows through the hot wire, through the main breaker, down the main bus bar, and into the circuit breaker. From there, it flows along the hot wire, across the switch and light, then back along the neutral wire and into the neutral bus bar, along the neutral bus bar wire, and back to the transformer. I've animated this using AC alternating current, but to make it easier to understand the path, I've shown it flowing in a single direction now. Okay, so what else might we find here? Well, we might find a double pole circuit breaker, which will let us connect to both bus bars to get 240 volts.
Double pole. So double pole.
Which we can use to power larger appliances like dryers, ranges, and air conditioning units. If we look at the dryer circuit example, we run the red hot wire from the circuit breaker, which is connected to the main bus bar number 2, and we run this to the receptacle. Then we run our black hot wire from the other terminal of the circuit breaker, which is connected to bus bar 1, and we connect that to the receptacle also. In this case, we have the neutral wire connected between the neutral bus bar and the receptacle, which will allow us to get either 120 or 240 volts from the output. Then we have a ground wire to provide a safe route for any fault current. Now we can either connect across the 2 hot wires for our 240 volt connection, or between the hot wire and the neutral wire to get 120 volt connection. We will also very likely find a GFCI circuit breaker, which stands for ground fault circuit interrupter. This will look something like this, and depending on the model you buy, you will usually have a pigtail neutral wire connected to it. GFCIs are required on certain circuits where outlets are used for places like kitchens, bathrooms, hot tubs, etc. You should check with the National Electric Code for exact details. The GFCI breaker has both the hot and the neutral flowing through it. This way it can measure the current flowing through both wires and ensure they are equal. If we took a standard outlet, we would take our hot wire from the breaker and connect this to the outlet terminal. Then we take the neutral wire and run this back directly to the circuit breaker to a specific neutral terminal. We then connect the pigtail wire into the neutral bus bar. This will provide the return path. And of course, we run the ground wire from the outlet back to the neutral ground bar. If we look at this example, the current is flowing normally until the guy sticks a screwdriver into the socket. The electricity then flows through him instead of the neutral wire. The GFCI is measuring the current in the 2 wires and notices that these are not equal. It then automatically trips the breaker to cut the power and save the man's life. We might also come across an AFCI circuit breaker. This stands for Arc Fault Circuit Interrupter. These are required for circuits feeding bedrooms, hallways, kitchens, etc. Again, check.
All the outlets now and lighting circuits are required to have arc fault in our new panels. So, they're very expensive. When we used to buy just a ground fault, do a ground fault plug, back in when they first came out and made it mandatory for us to use them was in the late 80s. And they, at that time, the ground fault circuit interrupter plugs like you have in your bathroom or in your kitchen were about $55. So in today's dollars, that's like $220 in today's dollars. So they were expensive. So we would they allowed us at that time to only put 1 in. So on the GFCIs, they have a double set of screws on the back, and one will say load, and one will say line, line in. And so the power from the panel will go to the line screws, and then anything that you want to have protected by that GFI, you can connect to the load side. So back then, we would connect all the places that were required to have GFCIs. So it was within 5 feet of a kitchen sink, bar sinks, all your plugs in your garage except for a washing machine, all your outdoor plugs and bathrooms were all required. We put all of those things on one GFCI plug. So I would get calls from people say half the plugs in my house don't work, so somebody popped the GFCI, I'd go to the house. I do a search, usually here in Santa Barbara, usually occurred after a rain. Because a lot of times you'd find the GFCIs would be outside, they'd get a little damp. They'd sense a difference in potential between the line in and the line out. And they pop the GFCI breaker and all of the circuits that were on that GFCI would go off, right? So I would go track down wherever the GFCI was. Push the little button. Say $50, thank you very much. And all their plugs would be working again. So, and I would teach them how to do it and where the plug was, because that's what we did back then. You'd put all of the GFCI circuits on one GFCI plug. Today, you can't do that. So each bathroom has to have its own circuit. Kitchen has to have at least 2 plug circuits. Outdoor plugs have to be on another circuit, garage plugs have to be on another circuit, so everything is divided out now. Everything is separated so you don't overload any circuit. So we're required to do that. And so now we would probably, instead of doing GFCI plugs, what is more traditional now is to do a combination arc fault GFCI breaker. It's a combination breaker that does both. I explain arc fault circuit breakers like this. I used to have a house over on the Mesa, and it was built in the late 50s. And when they built it, they put in a circuit breaker panel. It only had 8 breakers in it. And then they had one circuit for, it was a 3-bedroom house. And they had one breaker for all 3 bedrooms. And they had another breaker for just all of the lighting, and I think the whole house, the way it was set up. Anyhow, so, and then because it was built then, they didn't have central heat in the house. They had a wall furnace that went between the hallway and the living room. It faced 2 sides. And that was the heat for the whole house. So
Sorry, when did you say this was?
on the Mesa,
No, when was it? The 50s.
the house was built in the late 50s. I didn't live there in the late 50s. Okay, so the furnace was there. So at night, you close your bedroom door and you're sleeping and your bedroom's cold, especially on the Mesa, because it's like a nice box over there with the wind coming off the ocean. So what you would do, and each bedroom only had 1 plug, right? You have 1 plug in your bedroom. So in that plug, you'd plug in your TV, you'd plug in your cell phone charger, plug in your computer. And so you had a plug like this that had all these different plugs in it, number 1. And then because it was cold in your bedroom, you also plugged in a little floor heater, electric heater, so that you could keep your bedroom warm because it was cold and the heat from that wall furnace wasn't getting down there, and my wife would shut it off anyhow. So we had in the bedrooms, we had these little furnaces, right? I mean, little heaters, electric heaters. So people are stupid in general. So they would plug in like a little lamp cord, extension cord, to plug in the heater to get it to where they wanted it in the bedroom. And so when you get up in the middle of the night and you go to pee, you don't want to trip on that cord. So you put a rug over it so you don't trip on it at night. So this is the perfect storm for a fire. You got a lamp cord, you got a heater that's using about 1,500 watts. You've got a thin lamp cord that heats up like a toaster when you've got 1,500 watts going through it. And then you got a rug on top of it to start smoldering and catch on fire. So there was a lot of house fires all across the country because of this exact reason. And what arc faults do is when it senses a short between the hot and the neutral, it pops the breaker and it stops it before a fire can actually catch on fire. So when the insulation on that extension cord got to the point where it would start melting the insulation on it, short it out, it would pop the breaker before it had a chance to really start sparking and catch on fire. And that's what arc faults basically do. Ground fault circuit breakers sense if there's a leak going from usually from the hot to the ground. And so if there's a leak like that, then it's going to pop the breaker and you don't get electrocuted. Arc faults are to stop from like a fire starting from a short between the hot and the neutral. So they work in a couple different ways. Like that. Kind of easier to understand that way.
Now, pretty much everything has to have it, right? You said every plug.
Every plug and light, also lights have to have it now too. And they're expensive. They're about around $45 a piece.
Mm.
So regular circuit breakers, like for a Murray panel like this, they're about $4 a piece. The arc faults are about $45. So if I had 20 breakers times $4, it's $80. 20 breakers times $45, a lot more, $900.
If you break out a sub panel, an old panel, I would break out a sub panel. So if you do it the code right, be sure that the new sub panel has to have all new circuit breakers, right? You have to upgrade your old breakers as well, and that you leave behind in the main panel.
So that's a tough question because it usually depends on the inspector. So you can try, but I can't tell you that you can get away with it. It's supposed to have our
The code is if you upgrade your electric, you're meant to upgrade to the code.
Everything.
Yeah, right. Okay.
everything. You have to do it to the current.
I feel like a lot of people don't do that,
A lot of people don't do that.
or even like the sub-family too, or something.
A lot of people don't do it.
Yeah. Well, even just.
Or they'll do like, where it's really required to have those is in sleeping rooms, hallways, bathrooms, lighting circuits. And then they'll, like, for a living room or something, they'll do a regular breaker. Yeah. Or they'll use the GFCI's plugs instead of having the arc fault GFCI. They'll do it that way.
Or like the kitchen, you could use those, right? Instead of this. Same thing or no?
I would use a combination. For me personally, I use a combination breaker, and they're about $54. GFCI, AFCI combo breaker for a kitchen. Then you're meeting the code. You're doing what it's supposed to be. And I put that into my price when I'm bidding the job. I don't just bid electrical, but because I'm a general contractor, I'm not an electrician, but I figure for the way it's supposed to be done. You have to, you gotta see why, you know what that means. I'm on camera, I don't say.
For the National Electric Code for exact details. AFCIs work also by being connected to both the hot and neutral wires. Inside this circuit breaker is a circuit board which is measuring the circuit and monitoring for patterns which indicate an arc fault is occurring. These are installed pretty much identically to how we saw the GFCI breaker. Under normal conditions, the current flows through the hot, back through the neutral into the breaker, then through the pigtail and back through the neutral bar. But if, for example, a screw was accidentally inserted very close to the cable and removed the insulation to expose the copper wires, the electricity could now potentially jump across or arc from the hot wire and into the neutral. The arc is incredibly hot and causes most residential electrical fires. As the
This is what I was telling you about when the insulation melts. Causes this rapid short.
The arc occurs, it creates a unique signal in the electrical cable. The circuit breaker can detect this and will automatically trip to cut the power. Connected to the neutral ground bar will be a thick, uninsulated copper wire, which runs out of the bottom of the panel and off to the ground rod, which is pushed into the earth near the property. Under normal circumstances, no electrical current will flow through this wire. Its purpose is to dissipate high static voltages from things like lightning. This way, the electrical systems and equipment is protected from damage. Additionally, we'll also find a bonding wire to metal pipework in the property. This is to provide a safe route for electricity to flow should a hot wire come into contact with a metal pipe, and this way it will prevent a person being electrocuted if they were to touch the pipework. Okay, guys, that's it for this video.
Okay, I told you before that we have to provide our own grounding. So the Southern California Edison, or in my case, PG&E, they provide the electrical wires, the two hots and the neutral to the electrical panel, but we as a builder or as an electrician, we have to provide the grounding. So you need two types of grounding required by code. You have to have a cold water bond. Let me do this for a minute. Here's my house. And I have my, say I have my electrical panel over here. And this is the street, and I have my water coming in, and it comes into the front of the house here. So I'm required to have two grounds. I have to have a number 4, remember I said a number 4 solid wire going for grounds. I have to have a number 4 solid wire that goes to the plumbing connection here. And I have to have one of two things. I either have to have a grounding rod, which I'll show you over on the panel over there, or what's called a UFR ground or UFR ground. So UFER. Now, a UFR ground, I call it UFR ground. Some people call it UFR ground. I like UFR, but UFR ground is when you're doing new construction and you have a concrete footing and you put rebar in that footing. You attach a number 4 solid copper wire with a grounding clamp to it, and the wire has to be continuous. You can't wire nut it, you can't cut it or anything, and that's going to go to my grounding bus bar in my panel. So I have to have both. I have to have a cold water ground, and I have to have either a grounding rod, which is 8-foot copper rod that's driven into the ground. Here in Santa Barbara, if you're going to do a 200 amp service, a lot of times they're making us do 2 grounding rods. 2 grounding rods, and they have to be at least 6 foot apart. The wire has to be continuous. So if I had 2 grounding rods. I'd put one in here, put a clamp on it, put another grounding rod in here, minimum 6 feet, and then I'd run that to my grounding bus bar in the panel. So that if you're doing a retrofit or redoing your, upgrading your service where you're changing from 100 amp to 200 amp, a lot of times you're gonna have to do 2 grounding rods.
Do you know why that requirement's there? Why do they need the redundancy?
When they have to be grounded?
Why do you have to have 2?
2, because it's a lot of electricity. And some places you're not getting really a good grounding as you would from a UFOR ground. They have to be 6 foot apart because they're copper rods and they induce a magnetic field. So you need to have at least 6 feet apart so that the magnetic fields don't interfere with each other and induce electric current. So they have to be far enough apart to do that.
It's just to do with the soil conditions kind of thing, which is not.
It would be almost like if I had a transformer. And I had one coil here and another coil here, and they had induced a current in between them. It would be almost like that if you had a short. You'd be inducing a current
Yeah.
in between. So if somebody happened to be standing there when that happened, they would be dancing very rapidly.
And you said that's a Santa Barbara thing or the California thing or something? The
It's the
2,
National Electrical Code.
all the 2s now, like
Yeah.
national.
It's everywhere. Here, the best grounding you can have is a UFOR ground. I always thought this steel is a ferrous metal. And for 30 years, I thought this stood for, because you're using copper rod, copper wire, or not a copper rod, but a copper wire with a steel rebar. So I thought it was union with ferrous metal. It's actually a guy's name. And I found this out after, I only learned this about 5 years ago, okay? So I Googled it. Because I was, let's learn about UFOR ground. And so after World War II in Arizona, they used to store the munitions that were left over from World War II. So they had bombs and, grenades and ammunition of different sizes and sorts, and it was blowing up. Because in Arizona, it's very dry and you get static electricity. And so the static electricity was setting off the munitions. So this electrical engineer named UFOR came up with this, and it's been coded since he came up with this. And it stopped the problem, and it directs the grounding to the ground and to the lowest point. And it's really great grounding. UFOR ground. Copper wire to the lowest bar in the foundation. It has to be the lowest bar. And it has to be a number 4 solid copper wire, has to be continuous, that goes right to the grounding bus bar. And
Do you put that, when you're doing a new construction, you'll just have a coil of number 4 copper attached to the rebar when you do your concrete pour kind of thing? Is that?
We'll try to put it as close to where the electrical panel is going to be. The other part of the code says that that piece of rebar has to be at least 20 feet long. Lowest bar, at least 20 feet long. So we'll try to attach it to one that is, it doesn't have to be a solid bar 20 feet. It just has to be in a loop or something that's 20 feet. And then you attach it with a grounding clamp, and then you bring it out of the concrete pretty close to where the framing bay where the panel is going to be.
All right.
So that way it's already in the wall. And then when you're putting your bottom plate down, you just drill a hole for it. Yeah.
I missed what it's actually connected to. It's connected to the rebar, But what is that doing?
Well, the whole concrete's in the dirt.
Yeah.
So
So
it gives you a very big
big
grounding feeling.
path
Yeah,
to the ground.
yeah.
Now, instead of a concentrated low impedance one, you've got a
It distributes it over a big. area.
wide area, high impedance one to the ground itself, get a better. Is the idea you're getting a better ground connection?
Yeah, you're getting really a super ground.
We do this.
People ask, like, when you connect it to the pipe coming into the house. What if you have a plastic water line as your main feed line coming to the house? Well, when you have a feed line like that. The last 2 feet, this is plastic. The last 2 feet and where it comes out of the ground and goes into the house, this is required to be metal. So the actual grounding from the water pipe comes from the water.
Yeah.
There's enough ions in the water that it gives you the grounding. So minerals. So the actual grounding doesn't come from the pipe, it actually comes from the water itself. It's a pretty good ground. The other requirement they have is if you have a gas, when you're doing a new service, you have to do one more thing.
So is that the water in the metal pipe in the house, or is it the
No,
water
it's the
back
water that's going back to the city.
back to the main? Okay.
So the pipes in your house, you're getting grounding the same way. Every time that you have a pipe coming out of the wall, even if you use PEX or plastic piping in the house, you still have to have a metal pipe coming out of the wall here in Santa Barbara. There are places that they allow you to put PEX coming out, but we don't. You have to have a solid pipe. You have to have an L for where you put your angle stop on.
Doesn't that,
So we have to have a copper pipe there, so you're getting the grounding.
doesn't that actually have potential for leaks because I guess you've got those shark bite connectors to the PEX or something.
Well, they're not shark bites. They have special connectors that they make a special. They call them bullets. The pipes that come out of the wall that you put your angle stops on. And they make them with a PEX connector on this part. Before it makes the sweep and the bullet comes out of the wall. Don't get any ideas here, guys. So this is a PEX connector, so I can put, and then you have to clamp this really solidly onto a 2x4 stud or a block. So it's nice and solid. And then the PEX pipe just connects onto here.
You said it's the Santa Barbara local code?
I think it's national code.
Oh,
Well, no, as far as some places, they allow you to bring the PEX out of
check
the
that,
wall.
yeah,
Not here. You have to have solid pipe.
and that's for, do you know why that?
Yeah, because you could break the pipe coming out of the wall, whereas if you have this is a real solid connection
Okay.
for putting your angle stop on and everything.
Okay,
Yeah, so they want to have that solid connection. Same thing with, they have a flexible gas line that can go in the wall. It's called track pipe. But you have to make a connection and then have solid pipe coming out of the wall. Or where you connect your gas valve to, because if you were taking a pipe wrench or a crescent wrench and putting the angles, the cutoff valve onto that pipe. And you happen to twist it, you could break the connection, then you'd get gas build up in the wall. And a potential for an explosion, because you could get a huge volume in the stud bay, you could get a huge buildup of gas in there, and then all of a sudden somebody is smoking and kaboom. Yeah. Okay, so the other code requirement that they have when you're putting a new service in is if you have a gas water heater, you have a cold inlet valve here, and you have a hot water outlet here. The water comes in and then gets heated and goes out. And then you have a gas pipe with a shutoff valve. And then a flex pipe going to the valve on the water heater here for your burner. So again, a number 4 wire, you have to connect a clamp here with a wire, with a clamp here, with a wire to the solid pipe and clamp it here. And that way you're getting grounding for your cold, you already have grounding for your cold water because you put a clamp on the outside. You're getting grounding for your hot water now and also grounding for your gas pipe. So you have to do this also every time you do a service upgrade. You have to do this grounding. And this doesn't go anywhere. It just connects these 3 together. It's not connected to the panel or anything. It's just these 3 connections right here.
Because the cold water is also connected to the ground somewhere else.
On the outside.
Right.
Is it the same thing? What about is the water heater, the hot water heater one?
If you have electric hot water heater, it already has a ground going to the panel. So you don't have to do it there. You already have a green wire to the hot water heater, right? But on a gas hot water heater, the gas is not grounded any place till you put this in. And you have the potential of having the electric, it could happen. Somebody could ground a hot wire to the gas line, and then you have a potential for a problem. So by doing this, you've grounded the hot water and the gas. Yeah. I need to take a little break. I'm going to stop the recording. And
Put that. And where it steps.
okay.
Sort of like a dead space, between vertical and the concrete wall and then the real thing.
We're kind of getting short on time, so I'm gonna probably save this one other video that I have for next week. And then next week, I'm gonna do something hands-on.
Yeah, we have 2 choices for selecting the grounding reward. One with rods and other with.
Upper ground, yeah.
And upper grounds means that we should install the cable, upper cable to the mesh of the concrete, yeah,
Yeah, the rebar.
rebar. We have in concrete,
The lowest, it has to be the lowest bar in the footing.
we have the system of the mesh of metals still in the concrete.
Yeah,
With, when we are building the
this is for new
new
construction.
construction, not for the remodel.
No. For remodel, we use the grounding.
Only the,
Yeah. Or if we're just doing a service upgrade, we'll use the grounding rods.
thanks.
Yeah,
Sometimes they'll bend those too or no? Bend those too or no?
no. Some guys, like they'll hit a rock or something. And they'll try to drive it into the ground, they hit a rock and they'll cut it off. Cause they get frustrated. If the inspectors see it's cut, make you put a new rod in.
Are they supposed to be the 10.5 or 8?
They're 8 feet typically. When we were doing a remodel, so in Hope Ranch, we had to do 2. Here in the county, what I call Nolita, because it's not really the city of Nolita and it's not really Santa Barbara. So it's Nolita here in this area, 93111, right? On the other side of the freeway, on the tracks that are on that side of San Marcos, the soil's kind of loose, it's sandy soil. So in that area, they require 2 grounding rods also, even if it's a 100 amp panel. They still require 2 grounding rods.
I didn't do that today. It was part of some panel too, so it was just kind of weird. But they have to be within 6 feet of.
They have to be at least 6 feet apart,
Yeah.
at least 6 feet apart. Yeah, you can't put them right next to each other,
Yeah,
at least 6 feet apart. So when we're doing the wiring installation, we have wire strippers, and on the wire strippers, they have numbers. And the numbers stand for the sizes of wire. So you don't want to use the wrong number for the wrong size wire, because what you can do is you can partially cut it, and then it becomes a weak point and the wire will break off or something like that. So if I'm doing a number 14 wire, I want to make sure I'm using the 3rd slot from the bottom here. That's going to be number 14 wire. Number 12 is the second, number 10 is the bottom. And then as you go up, it gets smaller and smaller wires, but the biggest one is number 10 on these. The biggest size wire. These are for connecting wires together. We use Romex connectors, and I'm going to talk more about those next week. You can do regular household wiring with a nice drill and a bit and very basic tools. You need a razor knife. This is my razor knife. I like this because you can store blades in here, and you can switch the blade around if you want to switch it. And if you pull that blade out and push it again, it'll feed a new blade in. So it's pretty handy. But you don't have to have one like that. These are cheap though, like $99 or something. Then we need lineman pliers. Lineman pliers we use for twisting the wires together, because before you put the wire nut on it, you're supposed to twist the wires to get a nice good connection between the 2 wires. And then you should cut it off with only about 5/8 of an inch left over for putting the wire nut on it. Now, I like the wire nuts that have the big skirt on it like this, because in case you didn't cut it off quite short enough, you're going to make sure that all the copper is inside here where it's not going to short out. Gives you a good amount of protection so that you're not going to get any shorting with your wires. So I like those with the big skirt on them.
What's your professional opinion on the sort of the plug-in nuts?
The way goes.
Yeah.
I see some people are going to those now, where there's a bunch of videos now that show that they're using those. I find they speed things up for sure. When you're doing can lights, they have them built into them. So it makes it really so much faster for doing can lights now. You just push them in. So I use them for those purposes.
Okay.
They're impossible to use if you're using stranded wire.
Yeah. Right.
So if you're using stranded wire, you're going to be stuck with using wire nut. You just can't do stranded wire with it. So it has to be solid wire.
You can't use it, or I've been using them for a while trying to wire.
Doesn't the wire just kind of bunch up when you try to push them in?
No,
No,
I haven't had that issue yet.
Oh,
we have
you-
a testimony here.
Yeah, I've
You
been
use
using
those
them for a
ones
while.
with the flip with the
I
like
push it
lever,
with my hand, I mean, it just goes right in.
the ones with the like lever on them.
Yeah, the one, little one, the way goes, yeah.
Those are easier. 'cause
Yeah.
they-
Yeah, with
they
the
have
lever, I'm talking about the ones you just push
push
it.
in. Yeah, those are
Oh, okay. I'm talking a different one.
cheap.
Like the ones that come with the can lights, there's no lever.
Oh, the can lamp, okay, okay.
Yeah, you have to push them in. So it's
I haven't-
like
I haven't
if
used those yet.
you're trying to push a stranded wire into one of those, the wire's just gonna go and all the
Oh,
little
yeah,
wires
yeah,
are gonna come apart. You're gonna have a wire sticking
You're
out.
talking about the way it goes. Yeah.
You have to twist it. That's it. It works, but it's hard. You can just, tires.
I don't trust my wire nutting, so. I like to push.
We're gonna learn the right way to do it next time.
Good.
Okay, let's talk about color coding. For plugs and switches, on plugs, the little slot is the hot side. On plugs, the little slot is the hot side, the longer slot is the neutral. So if you're looking at the wire where you wire it up, don't use the push holes on the back either. Always use the screws.
Oh, you don't like those, huh?
I hate them.
Okay.
I can't tell you how many times I've been going into the box and you go to pull it out of the box and the wires just pop out and you got, a lot of times you're just working live and all of a sudden you have a live wire that's just right there, where you're working. They just pull right out. No problem. So I've got shocked a few times from people using much faster.
Yeah.
But you get a much more
But
positive.
isn't that what's happening on the fixtures that you're talking about? It's the same sort.
It doesn't happen with the
Fixtures.
ones from the light fixtures.
Yeah,
I haven't had that problem at all. It happens when you're trying to push the wires into a tight box and then you go to pull it out and it's just, you got a hot wire just sitting there. The screws. Yeah, go ahead.
I gotta tell everybody, I made up a alliteration, I guess you'd call it, that helps me remember which side the wide one goes to. It's just wide is white. So and white is neutral, right? So that's how I remember.
Yeah, so on the plug.
I never remember.
That's how I remember. Oh,
That's how you remember. The gold screws or brass screws are on the hot side. So you're going to connect your colored wires, your black wires or your red wires or colored wire of some kind to these are brass or gold. On the neutral side, they're going to be silver or chrome. So you're going to put your white wire on the silver screws. Now on the switch, and then on the bottom is a green screw. So the green is always ground, right? Always ground. So that's going to be down here. On my switch, what color are the screws? They're brass color. So we know we don't attach any white wires to this. When I have my electrical box, I've got my electrical panel here, and I have my circuit breaker, and I've got a black wire, and I've got my neutral bus bar, and I've got a white, this is a black wire coming from my breaker. I got a white wire coming from my neutral bus bar, and it's going to go to an electrical box here. This is Romex. They come in, and I'm gonna have a black wire and a white wire. And then I'm gonna have a Romex that comes here, and it's gonna go over here to a light fixture. And in my light fixture, I'm gonna have a bulb. And with wires coming in like this, and I'm gonna have a white wire. And I'm gonna have a black wire. My white wire is just going to get wire nutted together with this white wire. I'm gonna put a wire nut on it here. And wire nut those together, and then it's gonna go over here to my white wire, and I'm gonna wire nut it together there. white wire just goes through. My black wire is gonna go and get connected to my black wire here and get wire nutted together. Now my switch, I'm gonna connect one black wire to one brass screw and the other black wire to the other brass screw. Doesn't matter which way. All it's doing is either stopping the flow of electrons, or you close the, turn on the switch, and it's allowing the flow of electrons. So it doesn't matter which screw you connect to which wire. That's all, that's how the switch works. It's just a device that when you turn it on, it's going to allow the electrons to flow and turn on the light bulb. Okay? So no white wires get connected to this. The switches do have a ground screw. So the electrical code allows me, if I'm putting this in a metal box that's grounded, all metal boxes have to have a ground screw in them with a ground wire to it. If I'm putting this in a metal box, I don't have to connect the ground screw to a switch. The ground wire does have to go to the light fixture. But it doesn't have to be, because this, if it's a metal box, this is metal, it's got ground screw, it's got screws that screw it to the metal box. This is all metal, so you're actually getting grounding from the screws that hold this device to the metal box. If it's a plastic box, yes, you have to connect the grounding screw. On a plug, doesn't matter. You have to connect the grounding screw no matter what. So whether it's a metal box or a plastic box, you have to connect the grounding wire. If it's a metal box, you have to connect the grounding wire to the metal box and then run a pigtail or extension of that wire to the grounding screw here.
I like those smart switches too, like if they're not hooked up right, then they just won't work.
What's that?
The smart switches,
Smart what?
like the smart switches, like they have to be connected properly in order for them to work.
Yeah. Yeah.
What's a smart switch?
I don't really know why, but I know.
Smart switches communicate without being directly wired.
Oh, okay.
Or if you have a smart switch that you can control from your phone, it's connected to the Wi-Fi.
No.
So you're basically wiring it the same way. But it has an additional communication that goes to your Wi-Fi that you can control it with your cell phone. There's two different kinds. So I assume you're talking about the one that you can control with your phone.
Yeah,
But they also make a smart switch that communicates to another switch, like for a three-way. Three-way is when you walk into a room. And I can turn on, here's my light here. I can turn that light on here and then I can leave the room and turn it off over here. That's a three-way switch. 1, 2, 3, 3 places, but actually you only have 2 switches, and it takes a special switch. A three-way switch actually has the 2 brass screws and a black screw. So it has a third screw to it. So you need a 3-wire Wemex like this. If I'm using number 14, you would have to use 3-wire like this to wire it.
have you seen the blue ones? Have a blue one. They have a 12-3, but it's in blue case like that.
Yeah.
Oh, yeah. To let you know it's a 3.
I don't know, I just barely seen it.
I don't know. I haven't seen it.
Yeah, it's like blue.
Yeah.
You probably knows.
So I have a question.
Have you seen that?
The 14-3 or 12.
12-3 with the blue?
They are new, yeah. 12-3 is
They have a new color code?
14-3 is new color is blue,
Blue.
and 12-3 is new color is purple. They are new.
I haven't seen them. I haven't seen 'em.
Only for 250, it's not the best,
Okay.
only for them.
I haven't seen them.
They are new.
The colors.
This near code for the Rolex in the store.
What size is that? What size?
Two different colors. So 14 is blue
Yeah.
and 12 is purple.
Only for 250.
What rolls?
Yeah,
Oh, okay.
that's rolls.
Interesting.
Bring a piece.
That's new to me.
But
You'll
it's
take it next time.
It's probably because maybe guys are cheating on the color and or something, so they're doing something new to keep them honest. Who knows?
Short way.
But it's good because.
Maybe if they're making more money this way.
Very possible.
It's too easy to finding them, because 14.3 and 14.2, they were the same color.
So now 14.3 and 12.3 have two new colors.
Yeah.
That's only
It's not for 12.2 or 12
No,
or
no.
14.2.
And so you don't mistake any of them.
Oh,
That's awesome.
Yeah.
Actually, I love that. That's really good.
I'll give you a piece, Barney.
You got something?
That's really great. That's really great. Okay, so, when we're wiring a plug, we're just going to connect the white wire to the silver screw, the black wire to the brass screw, and the ground wire to the bottom. Now, if we're doing more than one, we're going to use what we call pigtails, which means we have I have a black wire coming in. I have a white wire coming in. And then I have electrical box, but I'm gonna put a plug here. But down the way, I want to do another plug down here in another box. So what I'm gonna do is I've got this Romex coming in. And I have another Romex coming in here. And what I'm gonna do is I'm gonna take these and join them together, but I'm gonna join them together with a third wire, a short little piece. Usually I make these about 12 inches long. And I'm gonna do the same thing with the white wires. And I'm gonna add another wire here, and I'm gonna join these together, twist them. And then join it together with a Romex connector. And I'm gonna use these to connect to my plug here. This way, my electricity continues on, and now I have my wires here for my next box. That's live, so it doesn't matter what I'm doing here, I still have my electricity going here. And if I want to do another one, I can do the same thing. I'll pigtail them and continue the wire onto another box down here.
How many boxes you can do that?
10.
big till 10.
I think 10 or 12, yeah.
Okay.
You can jump it for 10 boxes.
Yeah, but remember
Oh,
now,
walls and-
remember now that we have to have a separate breaker
Yes.
for every room, every bedroom, every room, for the hallway,
Right.
for the lights, it has to be on a separate circuit. So if I have a bedroom, I have to have 2 circuits. One for the plugs, one for the lights. Can't be attached anymore. Or you can't have the lights for the whole house on one breaker. So 10 or 12 circuits gives me a lot of plugs in a bedroom.
Yes.
Yeah, so remember, each room has to be divided then. So it's a lot of plugs. And if you had more than that, then you'd have to do another breaker. Just split them up into 2 breakers. Also, remember that we used to be able to do 2 breakers on 3-wire Romex. We can't do it anymore with the ARC circuit interrupter plugs. it'll pop. If you try to do that, we used to do it all the time. You'd run, and it would save on wire. You use one 3-wire Romex, and I could do 2 circuits, 2 bedrooms, run one circuit to one bedroom, run the other circuit to the other bedroom. And that, like if the house was long, you'd save on an extra wire to, like 50 feet of wire. Price of wire now, and you have to do 2 wires now for those 2 circuits because of the arc lengths. So the price of wire has really gone up. They have it under lock and key at Home Depot, and they have to walk you up to the front register to make sure. So you better get all your other shopping done before you buy your wire. Because they're gonna escort you to the checkout counter with it now. It's so expensive.
Like 20 minutes.
I feel like, right?
Yeah.
Okay. Well, I think that's all for tonight. Any other questions before we go? So simple, you can do a lot of wiring with just simple tools, simple, reasonable tools and do a good job. You need a nice drill though. You need a right angle drill really to do the wiring. When we meet next week, we're gonna go outside and there's some stations already set up. And we can, the holes are already drilled and so everybody will have a place where they can work on their own box and do some wiring and.
We have to bring, the tools or tools.
I'll have tools, but you can bring your own if you want to. Yeah, we'll have tools.
Okay.
Yeah, we have them here.
So do we have to call the power company then to get the box?
We'll have to call the power company to make sure the power shut off before you
Get in there.
get in there. I'm worried about you. Thank you, guys.
Thank you.
Thank you. Thank you.